Alright, Common Core Algebra 2, we're going to do a lesson here where we kind of add on to 4.6. This isn't really 4.6, but we need to talk about simplifying radicals and be able to really work with complex numbers. So, by the end of this lesson, you'll be able to simplify radicals and also called, or combine, like radicals. Okay, and this is probably the more important piece. And we're going to talk a little bit about complex numbers in there as well. So first thing, to simplify radicals, you want to think of this as a product. We want to write it as a product of a perfect square, so that's really important, and then just some other number. Now this perfect square piece is really important. What I mean by a perfect square is any number that has a integer square root. So that would be something like 4, because the square root of 4 is 2. 9 would be the next one because the square root of 9 is 3. We could skip a few and say like 49 because the square root of 49 is 7. We could skip a few more and say something like 121 because the square root of 121 is 11. So we want to take one of these numbers that would be in that list, anywhere in that list, 9, 16, 25, 36, 49, 64, so on and so on, and rewrite it as a product, meaning in multiplication. So this means multiply of that perfect square and just whatever the other number is. And now sometimes it's pretty easy. Like if we said the square root of 64, we don't even need to rewrite that as a product because the square root of 64 is in fact a perfect square, and we can just say that this is 8. Okay, now in the future we'll talk about it being plus or minus 8 in both terms, but since we're not really worried about functions right now, we're just going to say it's a positive 8. Okay, the square root of 98. Now that's a little bit more challenging because it's hard to look at 98 and say it is a perfect square and some other number. And in fact, we really want to say that this is the largest perfect square. Okay, in this case, 98 is divisible by 49, and when we do 98 divided by 49, we get 2. So I'm going to rewrite this as a product of 49 and 2, and really the square root of 49 and the square root of 2. And we do that because we can simplify the square root of 49 and we get 7. So we'd have 7 times the square root of 2. And we can do the square root of 2 in our calculators. We get some ugly number like 1.414. We don't want to do that though. We want to leave it as 7 times the square root of 2, and that would be it. Okay, now I added this third example in here to kind of show you how this combines when we talk about imaginary numbers. Now we talked before about complex numbers or imaginary numbers. That means the same thing. The negative sign here we're going to pull out as an I, because remember that's the square root of negative 1. So it's kind of like we have I times the square root of 12. And now we can simplify that. So we could say I, and then I know factors of 12 were like 6 and 2, but the problem there is neither one of those is a perfect square, so those are not the values I want to use. In fact, I need to choose my values intelligently, so 1 is a perfect square. In this case, I need to do 4 and 3 because those 4 is a perfect square, so I can rewrite that as 2 times I, so 4 became 2, we kept the I, and then we're going to rewrite it as the square root of 3. So that would be the simplification of the square root of negative 12. Okay, so that would be if we have like just one radical, or if we multiply two radicals together, we could simplify them like such. If we had radicals in two different terms like we do here, so we're combining, we're subtracting in this case, we're first going to only combine them if the radicals are identical. So here you see they are identical, the square root of 3 and the square root of 3. They're the same, so we can combine them. And we're going to treat the radical, or the radicand, that just means this right here, the radical is the square root, the radicand is the number underneath, as a variable, and combine our coefficients. So if we were to say treat it like a variable, you could think of an example like this, like really 7x minus 2x, and that would give us 5x. We just differ on our coefficients. It's the same idea here. Instead of x, we have the square root of 3. So 7 minus 2 is still 5 times the square root of 3. It would work the same way if we were adding. If this said like 6 square root of 2 plus 5 square root of 2, and again remember these two have to be the same, we'd get 11 square root of 2. So I basically treated it just like a variable. Okay, so that is it on simplifying radicals. That's all we're going to do for this lesson. It'll hopefully help us identify and work with complex numbers a little more. We simplified and combined like radicals. Big thing on combining like radicals, they have to be the same radical, and on simplifying radicals you want a perfect square times some other number. Okay, see you next time, guys.